First gate is AND gate here. Coming to AND gate, I told you that any logic gate is going to have the one or more than one inputs and only having the one output. It means it is allow the more than one inputs and produce the only single output. So here I am taking a two input NAND gate first. First I am taking the two input NAND gate. So for the NAND gate, what is the truth table? First we'll try the truth table. It means it will show the relation with the inputs and output. It means what is the input you are going to give and what is the output you are going to get. That is the shown from the we can observe from the truth table. And first let us take the two input AND gate. Two input AND gate. It means number of inputs are two. I'm taking those inputs are AB. AB are the inputs. AB are the inputs, and let me take Y is the output. Y is the output, and we call it's a AND operation. A and B. A and B. Now we are so with the two input variables. With the two variables, how many combination we can have here? It obviously here A and B is what? A and B is the binary variables. That is, A can have 0 or 1, B can have 0 or 1. So with these two binary variables, we can have the how many input combinations? It is about 2 power of 2 input combination. That is 4 combinations. Those are 0 0, 0 1, 1 0, 1 1. Okay. So these are the input combinations with the two input variables. Okay. Now what is the output of the corresponding AND gate here? So when you give the input for the AND gate 0 and 0, then it will give the output 0. To give the output 0. And when you give the output inputs as 0 and one input is 1, the corresponding output is 0, and in this case also 0. And when you're going to give the input as 1 and 1, then the output is going to be 1. Okay, it means when AND gate will pass through the two inputs, the and two inputs as logic 1, then the output is logic 1. The remaining cases, what is output? In the remaining cases, the output is going to be 0. Coming to the symbol, logic symbol, logic symbol. So I'm showing the two input AND gate symbol. You can have the more than two inputs also, but I have taken example two input AND gate. So I'm showing the two input AND gate symbol, taking two inputs and AND gate symbol. Okay, and my inputs are what? AB is the inputs, and output is Y. That is AB and B is the output. Now we'll see enable input and disable inputs. The third one is the AND gate will check for the enable input and disable input. It means coming to enable input. So we can say the input which is allowing the other inputs to pass through the gate is called as the enable input. Let me write down that one. The input which is allowing other inputs to pass through the to pass through the gate is called enable input. Is called enable input. Okay, the input which is allowing other inputs to pass through the gate is called as the enable input. Let's check for the enable input for the AND gate here. So we're having the two input AND gate, okay, and we know the inputs are there. For example, I'm having one input is 1. I know one input is 1 and I don't know the other input. I'm taking other input is x. Other input is x. And if this one is going to allow the other inputs to pass through the logic gate, then we can say that the one is going to be the enable input. I'm repeating again, the input 1 is allowing other input to pass through the logic gate, that is other input x through the logic gate, then we call is the enable input. Then now you can check whether the one is allowing x or not. Here, what is x here? X is a binary variable, so x can have the 0 or x can have the 1, right? So x can have 0, x can have 0 or x can have 1, right? So when x is 0, what is the inputs here? One input is 1, one input is 0, right? Means what is going to be output here? For AND gate, input is 1, output two inputs are 1 0, and the corresponding output is, you can check the table here. What is the corresponding output? It is 0. You can observe this on the screen. When the input is 1 and 0, the output is 0. If x equals 0, then you are going to get output is what? 0. Okay. And if with the one more possibility, the x can be 1. X can be 1, then the inputs are what? 1, 1 is input. For AND gate, the inputs are now 1 and 1, right? So for 1 1, what is the output? It is 1 only, right? So we are going to get 1. It means for giving the x equals 0, you are getting output 0. For giving the x equals 1, you are getting output 1. It means the 1 is allowing the x to pass through the logic gate. So what is the output here? We can say output is simply equal to the x. So we can say 1 is the enable input. 1 is the enable input. Now coming to, let's check for the disable input here. So let me give the definition for disable input. Now coming to disable input, the input which is not allowing, the input which is not allowing other inputs to pass through the gate is called as the disable input. Disable input. Okay. Let's check out for the let's go for the this AND gate. Okay. So I'm taking one input is 0 and I am taking other input is x. Other input is x. So if this 0 is not allowing the x to pass through this large AND gate, then we can say that 0 is the disable input. The same manner, the x is a binary variable, so x can have 0, right? When inputs are 0 0, what is the output of the AND gate? Answer me. The inputs are 0 0. What is the output of AND gate? It's 0 only, right? So output is 0, and again x can be 1 also. It's a binary variable. So when the inputs are 0 1, the output is going to be 0, again 0. It means whatever may be the x value, whatever may be the x value, what you are getting the output? Output is what? Output is 0. Whatever may be the x value, the output is what? 0 is the output. It means the 0 is not allowing X to pass through the gate. Here the 0 is not allowing the other input X to pass through the gate. That is irrespective of the input X, you can get the output as 0, right? So you can say the 0 is the disable input for AND gate, right? So it means where we use this enable input and disable input. For example, you're having any digital circuit. For example, you're having any two digital circuits, and for the two digital circuit, you're having the connection is AND gate, which are connected by the AND gate. If you want to enable that circuit, you can give 1 for the AND gate, and if you want to disable that circuit, you can give 0 for the that AND gate. So it is about enable and disable inputs. Let us see the switching diagram. Switching diagram. As we can use the logic gates as switches. In digital circuits, we can use the logic gates like switches. As to on the circuit or to off the circuit, we are going to use the logic circuit, logic gates here. Now here, so you are having input, you are having input voltage, and you are having the load. You are having the load, bulb. For example, you are supplying power to the a bulb in a room. A bulb in a room. Okay, it is a bulb here. Now, so here, remember that 0 means on, 0 means off or false, and 1 means on or true. Okay, so now tell me how we can connect the uh, these inputs A and B, which is A and B, how we can connect to turn on the bulb, to glow the bulb. So whether these are going to connect switch in series, or whether this A and B will be in parallel. Here two switches are A and B are the two switches, and you can observe this logic operation. So if you want to allow the power current through the bulb from the supply, how these switches A and B can be allowed, can be connected in series with the power supply and load, and in parallel with the supply and load. You can observe this logic diagram. When you are going to give 0 0, it will be 0 0 1, it will be 0 1 0 1 1 1 1, right? So to get the connection between the bulb and the input voltage, so in between this place, how the switches are going to be connected, whether A and B in series or A and B in parallel, right? I got one answer, series. Any other answers? Right, one more answer, series, right? So it's obviously series connection. So switches A and B, this is a switch symbol. A and B will be in the series, right? You can observe when A equal to 1 and when B equal to 1, there is a connection between the input voltage and bulb, and any one of the A is 0, any one of the switch is going to be off, then there is no connection. That is A equal 0 or B equal 0. You are going to get the disconnection, 0 output. When both are 1, you are going to get the connection. There is a switching diagram. So Next one is for three inputs. So I'm going to conclude the class in 5 to 10 minutes. If you are interested, I will continue the class. Otherwise, I will end in 5 to 10 minutes. So how many of you interested? You can post in chat box privately to me, private message. If you're not interested, you can place not interested also. I don't mind. As it is afternoon session, I'm not going to force you. A, B, C. For three inputs, the output is Y. Tell me how many input possibles, input combination can we have for three inputs. For three inputs, the number of input possibilities. It's about 8, right? So total 8 possibilities. Total 2 plus 3 possibilities. Those are 8 possibilities, and those are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So coming to the AND gate, the output of AND gate is going to be logic 1 only when all the inputs are 1. I'm repeating again, the output of logic gate is going to be logic 1 only when the output of logic gate all the inputs are 1 only. That is only in this case when A equal to 1, B equal to 1, C equal to 1. In that case only the output is going to be logic 1. In all remaining cases, the output is going to be what? The output is going to be 0. I'm taking the big 0. Uh, so here remaining cases the output is going to be 0. Okay, let me show you the symbol for three inputs and AND gate A, B, C. Output is ABC. Okay, so it is about the AND gate. Okay, and we'll discuss the remaining logic.